Alright, let's dive into the wild world of chemistry. The magical land where atoms dance, molecules mingle, and reactions throw parties like it's 1999. Picture this. You're in a laboratory, surrounded by beakers bubbling with mysterious concoctions, while a mad scientist cackles in the corner wearing safety goggles that could rival any fashion statement. That's right, it's chemistry time, folks. Now, let's talk about atoms. They're like the building blocks of the universe, the Lego pieces of reality. You've got your protons, neutrons, and electrons all hanging out in their atomic clubhouse, throwing atomic high fives and sharing electrons like they're trading cards. And when these atoms get together, they form molecules, the odd power couples of chemistry. Oxygen and hydrogen? They're like the Brangelina of the periodic table, creating water wherever they go. But wait, there's more. Let's break down some chemical reactions, shall we? It's like chemistry's version of a soap opera. You've got your reactants, the drama queens of the equation, throwing shade and causing chaos. Then suddenly, out of nowhere, the catalyst swoops in like a superhero, speeding up the reaction and saving the day. And when the dust settles, you're left with products, the aftermath of the chemical showdown. It's like watching a reality TV show, but with molecules instead of housewives. Now, let's add a dash of humor to the mix. Imagine a carbon atom walking into a bar, strutting its stuff like it owns the place. The bartender says, "Hey, why the long electron cloud?" And the carbon atom replies, "I'm just here for a good time and some covalent bonding, baby." Cue the laughter track and the clinking of test tubes. In conclusion, chemistry may seem daunting, but it's really just a cosmic cocktail party, where atoms mingle, reactions sizzle, and the periodic table is the guest list to end all guest lists. So, grab your safety goggles, hold on to your electrons, and let's get this chemistry party started. Embrace the chance to study now, as your success solely depends on you. Seize the opportunity, and let your determination and effort pave the path to knowledge and greatness. Remember, do the things to yourself because nobody else will. Title: Exploring the Foundations of Chemistry. A comprehensive guide to basic relationships in inorganic chemistry. Introduction. Welcome to the wonderful world of chemistry, where atoms, molecules, and reactions come together to form the fabric of our universe. In this comprehensive guide, we will delve into the basics of inorganic chemistry, exploring fundamental relationships and equations that govern the behavior of matter. From stoichiometry to chemical bonding, we will break down complex concepts into digestible chunks, providing examples and exercises to reinforce your understanding. So, put on your thinking cap, and let's embark on this journey through the building blocks of inorganic chemistry. Chapter 1. Stoichiometry. Stoichiometry is the study of quantitative relationships in chemical reactions, allowing us to predict the amount of products formed or reactants consumed. The fundamental equation used in stoichiometry is the balanced chemical equation, which represents the reactants and products of a chemical reaction in their correct proportions. Example: consider the reaction between hydrogen gas, H2, and oxygen gas, O2, to form water, H2O. The balanced chemical equation for this reaction is 2H2 grams plus O2 grams 2H2OL. This equation tells us that 2 moles of hydrogen gas react with 1 mole of oxygen gas to produce 2 moles of water. Exercise 1. Question: in the reaction between calcium chloride, CaCl2, and sodium carbonate, Na2CO3, calcium carbonate, CaCO3, and sodium chloride, NaCl, are formed. Write the balanced chemical equation for this reaction, and determine the stoichiometric coefficients for each reactant and product. Explanation. First, we need to write the unbalanced chemical equation for the reaction. CaCl2 plus Na2CO3 CaCO3 plus NaCl. To balance the equation, we adjust the coefficients to ensure that the number of atoms of each element is the same on both sides of the equation. After balancing, the equation becomes CaCl2 plus Na2CO3 CaCO3 plus 2 NaCl. Now, we can determine the stoichiometric coefficients. Calcium chloride, 1 sodium carbonate, 1 calcium carbonate, 1 sodium chloride, 2. This tells us that 1 mole of calcium chloride reacts with 1 mole of sodium carbonate to produce 1 mole of calcium carbonate, and 2 moles of sodium chloride. Chapter 2. Chemical bonding. Chemical bonding is the attractive force that holds atoms together in molecules or ions. The key concepts in chemical bonding include ionic bonding, covalent bonding, and metallic bonding. Example: let's examine the formation of sodium chloride, NaCl, which involves ionic bonding. Sodium, Na, has 1 valence electron, while chlorine, Cl, has 7 valence electrons. When sodium loses its valence electron and chlorine gains it, they form ions with opposite charges, Na plus and Cl, which are attracted to each other due to electrostatic forces, resulting in the formation of NaCl. Exercise 2. Question. Explain the formation of covalent bonds in a molecule of hydrogen gas, H2, using Lewis dot structures. Explanation. In a molecule of hydrogen gas, H2, each hydrogen atom contributes 1 electron to form a covalent bond. This can be represented using Lewis dot structures, where each dot represents a valence electron. For hydrogen, which has 1 valence electron, the Lewis dot structure is H. When 2 hydrogen atoms come together to form a molecule of hydrogen gas, they share their valence electrons to achieve a stable configuration. The shared pair of electrons forms the covalent bond between the 2 hydrogen atoms. This sharing of electrons allows each hydrogen atom to achieve a full outer shell, resembling the noble gas helium, He, which has 2 electrons in its outer shell. Chapter 3. Periodic trends. Periodic trends refer to the patterns and the properties of elements as you move across a period or down a group in the periodic table. Key periodic trends include atomic radius, ionization energy, and electronegativity. Example: let's explore the trend in atomic radius across a period in the periodic table. As you move from left to right across a period, the atomic radius decreases. This is due to increasing nuclear charge, which pulls the electrons closer to the nucleus, resulting in a smaller atomic radius. Exercise 3. Question. Compare the trends in ionization energy and electronegativity as you move down a group in the periodic table. Explanation. As you move down a group in the periodic table, both ionization energy and electronegativity decrease. Ionization energy is the energy required to remove an electron from an atom, while electronegativity is the tendency of an atom to attract electrons in a chemical bond. The decrease in ionization energy down a group can be explained by the increasing distance between the outermost electrons and the nucleus, as well as the shielding effect of inner electron shells. As a result, it becomes easier to remove outermost electrons, leading to a decrease in ionization energy. Similarly, electronegativity decreases down a group because the outermost electrons are farther from the nucleus, reducing the attraction between the nucleus and the electrons. This makes it less likely for atoms to attract additional electrons in a chemical bond, resulting in a decrease in electronegativity. Conclusion. Inorganic chemistry encompasses a vast array of topics, from stoichiometry to chemical bonding to periodic trends. By understanding the basic relationships and equations that govern these topics, we can unravel the mysteries of the chemical world. Through examples and exercises, we can reinforce our understanding and master the fundamentals of inorganic chemistry. So, keep exploring, keep experimenting, and let the magic of chemistry guide you on your journey of discovery. Absolutely. In the world of online content, engagement is key. Liking, sharing, and commenting on a video not only show appreciation for the content, but also play a crucial role in increasing its visibility and importance. When viewers engage with a video by liking it, sharing it with their social networks, and leaving comments, it sends positive signals to the platform's algorithms, indicating that the content is valuable and worth promoting to a wider audience. Moreover, subscribing to the YouTube channel hosting the video is another important step in building a community of loyal followers. Subscribers receive notifications about new uploads, which helps to maintain their interest and encourages them to return for more content in the future. Additionally, a higher number of subscribers can attract sponsors and advertisers, further supporting the content creator and enabling them to produce more high-quality videos. So, if you find the content informative, entertaining, or helpful, be sure to show your support by liking, sharing, and commenting on the video. And don't forget to hit that subscribe button to join the growing community of viewers who are passionate about the channel's content. Together, we can help spread knowledge, entertainment, and inspiration to even more people across the digital landscape.